Hello everyone and welcome to SewerU, Sewer University. We're going to talk today about the history of sewers and clean water in Northeast Ohio, specifically the greater Cleveland area. I am Frank Greenland. I'm the Director of Watershed Programs. This presentation is available on our website at NEORSD.org/SewerU. Okay, the district, since its inception, started to put in what we call automated regulators. These were put in the biggest pipes, those biggest interceptors, where we realized the flows weren't that great, and if we use an inflatable dam or a hydraulic gate, when it rains, we could actually lift the gate or inflate the dam and keep that combined sewage in the pipe instead of overflowing to the environment. We had these at 26 or 29 locations, and they were actually quite a good advance, and they lowered that 9 billion gallon total somewhat. This is just a quick shot of an inflatable dam. And you can see it's not fully inflated, but it's partially inflated, and you can see the combined sewage backing up behind it. If we didn't inflate that dam, this is the pipe that's heading out to the environment. And so we're storing it like we're storing it in a swimming pool, although we're storing it in a pipe. And that has resulted in reduced combined sewer overflow discharges to the environment. This is what a combined sewer is like. This is what one combined sewer overflow looks like. This is on Mill Creek. Warner, Turney area. This is Mill Creek Falls. You can see the flap gate. That water coming over that portion of the falls is combined sewage in a rain event. And this overflow was very large, over 100 million gallons annually. The good news is because of district investment in the Mill Creek tunnel system, this overflow is gone. And that's a great thing. So there's no discharge at this point. And across the river, across the creek, the Metro Parks has built a nice pavilion and platform educational facility. So it shows how good environmental investments not only help in terms of water quality, but are good public investments as well. This is our combined sewer area. It's color-coded, 3 different colors. And again, this is primarily City of Cleveland and some parts of the certain inner ring suburbs. The green area is the easterly treatment plant combined sewer area. In tan is the westerly combined sewer area, and the pink color is southerlies. And you can see little red dots along the streams. These are the locations where those overflows dump into the receiving water. So all the urban streams in our service area have at least one overflow. You can see Doan Brook in the heart of the green area has multiple discharges. The Cuyahoga River has a ton of discharges as well, as does Mill Creek, Big Creek, Euclid Creek, and others. All told, 124 combined sewer overflow outfall pipes where the pipe dumps to the water body across the service area. So what's the problem? When combined sewers discharge, the primary impact is bacteria levels, E. coli. I mean, we've all heard about E. coli outbreaks. Well, E. coli is harmful from a recreational aspect. So when it rains, you're going to see E. coli levels start to elevate, both in the streams and at the lake. Now, the district is very active in public notification. We sample our beaches daily in the recreation season, post those results, so we're always warning the public what that E. coli level looks like at the beach so they can make good decisions about whether or not they want to go in the water body. And our beaches are monitored as much as any in the nation, 7 days a week. Floatables are another issue in combined sewer discharges, more of an objectionable aesthetic issues. I'm not going to elaborate on what comprises floatables, but you can guess whatever you flush down the toilet or whatever washes off the street can end up in an overflow, getting over that weir. And if it floats, it floats. And it will float over the weir and get out to the water body. So this is more of an aesthetic issue, but it's not great. It's not good at all. And so that's another impact of combined sewer overflows. Sometimes you get weird things coming out of outfalls. We had an incident where a local entity dumped some grease into what they thought was a combined sewer heading to our treatment plant, and it was not a combined sewer heading to our treatment plant. It headed straight to Kingsbury Run. So we had a bit of a cleanup issue, and we took care of that, and the industry did their part. But it shows you what can happen coming out of combined sewer outlets. You asked the question earlier, and this is the graphic. 9 billion back in the 70s. It's 4.5 and going down. We're recently completing some more work, so it's going to go down. We're going to cut it to less than $500 million at a $3 billion investment. Combined sewers are pervasive across the Midwest, the East Coast, and the upper Northwest. The oldest urban industrial centers were built with combined sewers. The federal government in 1994 developed a combined sewer overflow control policy that applies to any community or regional sewer district with combined sewers. And so what it required us to do was develop plans to reduce combined sewer overflows to improve water quality, basically, is what it came down to. A consent decree is an agreement between the sewer district and the federal government and Ohio EPA on the terms and conditions of our program going forward. Which projects would we do over what time period? So a consent decree is a judicial action. So it's a binding action entered into court, and the district is under a 25-year consent decree to implement improvements to continue to reduce that total over time. And I think we're in the year 7 or 8, something like that, signed in 2011, I believe. So we're well on our way. Without getting too detailed, the primary investments in combined sewer overflow control going forward will be the construction of storage tunnels, deep underground, big tunnels, 24-foot diameter, and other sizes. And what happens is the overflows that once went to the receiving stream will get dropped into the tunnel, and they get held there. There's a lot, 50, 60, 100 million gallons of storage in those tunnels, and we hold that flow in wet weather, and then all of that flow goes through our treatment plants for really great treatment. So you've taken a raw discharge of wastewater and stormwater, and you've captured it, prevented it from impacting the stream, and then providing really good treatment before it's discharged. So that's a major environmental advancement. So tunnels are the big thing. There's a whole host of other projects. These are the locations of the major tunnel network that we're going to construct, and we're up in the easterly district right now, primarily with the Euclid Creek Tunnel, which is complete. Dugway Tunnel is under construction. Doane Valley and others are going to follow. So we're well on our way on the east side, and we're starting to move to the westerly district and other areas for the construction of the tunnel. So you can kind of see where these tunnel segments will be aligned over time. And we started with Euclid Creek because we've got a beach, Euclid Beach, and there are major combined sewer overflows near that beach. So this was a 3-mile tunnel, 24 feet in diameter. It'll hold 60 million gallons of combined sewage per event. Every time it rains, we can store 60 million gallons, which is a lot. This gives you some idea of the scope of these projects. This is the tunnel boring machine that is dropped down, and you put the mole in the hole, and it rolls for 3 miles until it comes out a couple years later. So this was named Mackenzie. This is the mining machine for Euclid Creek. That tunnel project ran beautifully. The Euclid Creek Tunnel is a 24-foot diameter, finished inside diameter. And you can see an individual in front. So you get some appreciation of the scope, magnitude of these projects. Many of the large major municipalities have employed tunneling approaches, particularly when you have an appreciable number of combined sewer overflow volume. So Chicago's got a tunnel network. Columbus is currently employing a tunnel network. Toledo, other municipalities across the country have utilized tunnels, but it's not just tunnels. I don't want to give you an idea that it's just tunnels. We try to do things in the existing combined sewer, so maybe you could raise that weir, cheap and effective. And we've done that where we thought we could do that. Some areas are served by pump stations. Maybe we upsize the pump station. Again, relatively cheaper than a tunnel, but still effective. We've used green infrastructure, and there's a slide in here on that. Maybe we can better manage stormwater at the surface instead of letting that stormwater get into the combined sewer, and we've done that, and other communities are doing that. So there's a number of different options. When you've got 9 billion gallons and you've got a very stringent federal target, tunnels prove to be fairly cost effective on a $1 per gallon capture basis. But we look for every opportunity we could find to to try and minimize the cost, but also maximize the effectiveness of our program. So we're not really that unique as opposed to other communities. That's Sewer University.